Hey there, math hoppers. In this video lesson, we'll learn all about the 6 trigonometric functions and how to solve problems with them. So this is the basis for right triangle trigonometry. And if you remember learning about similar figures, those figures that had the same shape but they were different sizes, because even though they had congruent angles, the side lengths were different but proportional, well, that's the basis for right triangle trigonometry. So if you remember everything about similar figures and you think about what a right triangle is, since all right triangles have to have a 90-degree angle, all right triangles need to be similar is one of the acute angles to be congruent. Because if you have one acute angle and a 90-degree angle congruent, then the third is going to be congruent, right? If you have two angles in a triangle that are congruent, the third has to be. So all right triangle trigonometry comes down to is one acute angle called theta in a right triangle, and it defines 6 ratios of side lengths. So that's it. We got right triangles and we have 6 ratios of side lengths, and that gives us trigonometry. And yes, we have a new variable. Theta is just a variable. It's a Greek symbol. We use Greek symbols as variables for angle measures. Where we used letters for side lengths, we'll use Greek symbols for angle measures here. So these 6 ratios, each of these ratios is a function of theta for 0 degrees to 90 degrees or 0 radians to pi over 2 radians. So we're going to be able to do a lot of things that we've done with functions for these relationships. So right triangle trigonometry comes down to, you guessed it, a right triangle. Right here we have a right triangle. We have an acute angle theta identified. And if you're looking at this angle, the hypotenuse is going to be side length BA no matter what. Hypotenuse is always going to be the longest side. It'll always be across from the 90-degree angle. But in relation to this acute angle theta, BC will be the opposite side because it is across from that angle. AC will be the adjacent side because adjacent means next to, and it is the leg next to that angle. So when you're solving these problems, you're going to have to really be careful because the opposite and adjacent side lengths are in relation to which angle is being referenced. So if we have angle theta, which is an acute angle within this triangle ABC, or any right triangle, then the following ratios apply. We have the sine of theta. Sine is abbreviated SIN of theta, and it is equal to the length of the opposite side over the length of the hypotenuse. Next, we have cosine. Cosine is abbreviated COS. It is equal to the length of the adjacent side over the hypotenuse. Then we have tangent. Tangent of theta is abbreviated TAN, and again, we put the theta symbol there. It's equal to the length of the opposite side over the adjacent side. Now, you're probably familiar with sine, cosine, and tangent. You learn about them in geometry. But we are going to expand to 6 ratios. Each of these ratios has a reciprocal function. So the reciprocal for sine is cosecant. Cosecant is abbreviated CSC, and it is equal to the hypotenuse over opposite. Or you can think of it as 1 over sine. That's what a reciprocal is. If you know sine is 1/2, cosecant will be 2 over 1. It's 1 over sine. It's the reciprocal of sine. So what's the reciprocal of cosine? The reciprocal of cosine is secant. It is abbreviated SEC, and it is either equal to hypotenuse over adjacent, or again, you can think of it as 1 over cosine. All right, now you will have to remember which of these goes with each other. So which is the reciprocal for which? You can remember that sine and cosecant go together because a function and its reciprocal function never start with the same letter. So sine and cosecant go together. Cosecant is the reciprocal of sine. They don't start with the same letter. Secant is the reciprocal of cosine. They don't start with the same letter. So what's the reciprocal of tangent? Well, this one's the easiest. It actually sounds like it goes with tangent, and it's cotangent, abbreviated COT, and it is adjacent over opposite, exactly the flip of what tangent was. Or you can think of it as 1 over tangent. Remember, these 3 on the right are the reciprocal functions, and you do have to remember which function they go with. All right, so moving along. This is where SOH-CAH-TOA comes from. I'm sure when you think trigonometry, you think, oh, SOH-CAH-TOA? Or maybe you've never heard of SOH-CAH-TOA. All SOH-CAH-TOA is a mnemonic device to help you remember what the ratios for sine, cosine, and tangent are. So SO is SOH. S stands for sine. The O is opposite. over hypotenuse. So if you write down SO on your paper, you'd say sine opposite hypotenuse, and you would remember the ratio for sine. Now, if you're looking at the triangle, remember, if we have that red angle theta identified, opposite is going to be across from there, so it's going to be BC over hypotenuse BA. All right. Now, CAH is CAH, and it sounds really strange if you have a Boston accent, I'm sure, but I do not. So the C is cosine, and it's equal to the side length of the adjacent side length over the hypotenuse. So if you remember CAH, CAH, you remember cosine is adjacent over hypotenuse. Okay. Last but not least, I'm sure you figured out TOA. TOA is the most fun to say, I think. T stands for tangent. O opposite, A adjacent. So if you remember TOA, you think tangent opposite adjacent. And you'll know it's opposite over adjacent. And that's how you can remember them. So if you remember SOH-CAH-TOA and you remember which functions are reciprocal of which, you've got all 6. And it's very, very handy. All right. Let's look at one other way to represent tangent because this will actually be super helpful. We know that sine is opposite over hypotenuse. We know that cosine is adjacent over hypotenuse. What would happen if we divide sine divided by cosine? So we get this ugly division, right? We have a fraction over a fraction, and it's a hot mess. But we're going to clean it up. So we have opposite over hypotenuse divided by adjacent over hypotenuse. Remember, when you divide by a fraction, you keep the top, change division to multiplication, and flip the bottom. So that's what we'll do. We will wind up with opposite over hypotenuse times hypotenuse over adjacent. We will simplify this by dividing out hypotenuse, and we see that when we do sine divided by cosine, we get opposite over adjacent. Well, that's OA. That's equal to tangent. So tangent is equal to sine over cosine, which would also make cotangent cosine over sine. This form of tangent will be really, really helpful throughout trigonometry, so it's worth memorizing. Okay, so like I said, if you remember SOH-CAH-TOA and you remember which functions are reciprocals of one another, you will be able to find all 6 trigonometric functions. So let's go over it one more time. Sine opposite over hypotenuse is the reciprocal of cosecant, hypotenuse over opposite, or you can think of it as cosecant is the reciprocal of sine. Cosine, adjacent over hypotenuse, goes with secant, hypotenuse over adjacent. And last but not least, tangent opposite over adjacent goes with cotangent adjacent over opposite. Those are your functions and reciprocal functions. You remember that in SOH-CAH-TOA and you're golden. All right, let's do a really easy problem. So for this one, we've given a right triangle. Angle theta is identified. 2 side lengths are identified, and we want to solve for all 6 trigonometric ratios of theta. Well, the problem is we only have 2 side lengths. So step 1, we have a right triangle. Right triangle should make us think Pythagorean theorem. We are going to use the Pythagorean theorem to determine the 3rd side length. Remember the Pythagorean theorem? A squared plus B squared equals C squared, where A and B are those legs, and C is the hypotenuse. So we have 2 is a leg, 5 is a leg, the unknown is a hypotenuse. So we're going to go ahead and set it up as 2 squared plus 5 squared equals x squared. So 4 plus 25 equals x squared. 29 equals x squared. 29 is not a perfect square, so we just take the square root of both sides. We get that x is equal to the square root of 29. That's as exact as we're going to get. Don't take out your calculator. Don't get a decimal value. Just write it as square root of 29. Now we'll use SOH-CAH-TOA and the reciprocal identities to write all 6 ratios. Sine. Remember, so opposite over hypotenuse. That's going to be the opposite of theta is 5 over the hypotenuse is square root of 29. Remember, you can't leave radicals that aren't perfect squares. You can't leave irrational values in the denominator. So we're going to rationalize the denominator, which just means multiply the fraction by rad 29 over rad 29. So we get 5 rad 29 over 29. All right, cosecant. Cosecant is 1 over sine, right? It's just the reciprocal of sine. Since I already solved for sine, I'm just going to flip this. I know cosecant is the square root of 29 over 5. Cosine, adjacent over hypotenuse. Looking at theta, there's my adjacent, it's 2. Hypotenuse is rad 29, so we get 2 over rad 29, but again, we have to rationalize the denominator. We can't leave that rad 29 in the denominator, so we get 2 rad 29 over 29. Secant, that is the reciprocal of cosine. So I know cosine is 2 over rad 29. So this is just 1 over cosine. So I'm going to take the cosine and flip it, rad 29 over 2. Tangent, opposite over adjacent. Opposite again is 5, adjacent is 2. Tangent of theta is 5 over 2. Cotangent, that's just going to be either opposite over adjacent or 1 over tangent. It makes no difference. And it's 2 over 5. That's it. Next type of problem you'll see, they'll give you a single trigonometric ratio and ask you to find all 6. This really isn't any different than the problem we just did. These seem a lot harder because you don't usually get a diagram. So you'll get a problem that looks like this. It'll say let theta be an acute angle so that the sine of theta is 12 over 13. Determine the other 5 trig functions of theta. All right, step 1, draw a right triangle. Label the opposite and the hypotenuse. Why are we labeling opposite and hypotenuse? Because they gave us sine. So based on the value of sine, that's what we're labeling. Here's my right triangle. I picked a theta. I know opposite is 12 because it's in the numerator of sine. I know the hypotenuse is 13 because it's in the denominator of sine. That's it. Step 1 done. Step 2, again, use the Pythagorean theorem to calculate the length of the missing leg. But remember, if you're given sine or cosine, that means you have a hypotenuse. So it's not 13 squared plus 12 squared. You have to do 13 squared minus 12 squared. Okay? So 13 squared minus 12 squared equals x squared. We get 169 minus 144 equals x squared. We get 25 equals x squared. We do a little happy dance because 25 is a perfect square. X equals 5. Pop it in the triangle. Now we use SOH-CAH-TOA and the reciprocal identities to write all 6 ratios, just like we just did. So we already have sine. I'm not going to rewrite it. Cosine is adjacent over hypotenuse. So the adjacent, remember, here's theta. Adjacent is next to. That's 5 over hypotenuse of 13. So that's 5 over 13. Now tangent, opposite over adjacent. Opposite is 12. Adjacent is 5. So it's 12 over 5. Cosecant. Cosecant's 1 over sine. What's sine? They gave us sine. 12 over 13. So then cosecant is 13 over 12. Secant is 1 over cosine. We do know cosine. We already solved for it. Cosine's 5/13. So secant is 13/5. Cotangent, 1 over tangent. We know tangent. We already solved for it. It's 12/5. So cotangent is going to be 5/12. That's it. All right, lastly, they can ask you to solve a right triangle. This problem, exactly like the others, is just worded again differently. It'll say a right triangle with a hypotenuse of 8 centimeters includes a 38-degree angle. Determine the measures of the other 2 angles and the lengths of the 2 legs of the triangle. All right, it's kind of silly that they ask you for the other 2 angles. So let's start with determining the angles, because it's silly that they ask us. First of all, it's a right triangle, and they told us it has a 38-degree angle. It's a right triangle, so we know it has a 90-degree angle. We also know it has a 38-degree angle. We also know all 3 angles in a triangle add up to 180. So 180 minus 90 minus 38 is 52. 52 is the other angle. The other 2 angles are technically 90, because right angle, you need a 90 degree, and 52. All right, now we can work on the side lengths. But again, I'm going to want you to draw a triangle and use SOH-CAH-TOA and the information given, and this time we're going to set up an equation. So here's my right triangle. Let's look at what I put in. I put in 38. They gave me that. I put in my little right triangle symbol because it said it was a right triangle. We already solved and got 52, so we put that in. And they told us the hypotenuse was 8. So I made sure to put 8 across from the right angle. And then I just labeled the sides A and B. So since we have the actual length of the hypotenuse, we can either use sine or cosine to solve for the other 2 sides. Because remember, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So it doesn't matter. I could say the sine of 38 is b over 8. Or I could say the cosine of 38 is a over 8. I'm going to stick with sine. You can use whatever you'd like. Well, you can use sine or cosine. Sine of 52. Well, what's the sine of 52? Sine of 52 is opposite, so that's the unknown, over hypotenuse. So here's my equation. Sine of 52 equals a over 8. Believe it or not, I can solve this like I solved any other equation. Multiply both sides by 8 to get a by itself. When I do that, it looks like this. My 8s will divide out. I get A equals 8 times the sine of 52. I have to put that into my calculator. I get A is 6.30408, or A is approximately 6.3. We're going to do the exact same thing and solve for B. I'm going to again use sine. So if I want to use sine and solve for B, I'm going to say the sine of 38 because B is across from 38. The sine of 38 is opposite, which is B, over hypotenuse, which is 8. Set it up like an equation. Again, solving for B, multiply both sides by 8. Get rid of the 8 on the right side. My 8's divide out. I get B equals 8 times the sine of 38. Calculator does the work from here. When I put that in, I'm going to get B equals 4.9. I actually get 4.90813 whatever, but it rounds to 4.9. That's it. Got questions on right triangle trigonometry? You should be subscribed to our YouTube channel. Our next lesson will be on those special right triangles, but until then, take it easy.